Aloha, I'm Matt Limtiako with Navigating Change.
And I'm Marcy Grabowski with the Hawaii Ocean Observing System.
So Marcy, we've been hearing a lot about this whole climate change issue. Can you shed some light on what climate change actually is?
Sure, Matt. We're all familiar with weather. That's the day-to-day change in temperature, cloudiness, rainfall, and moisture. But climate is a bit different. It's the long-term pattern of weather on our planet.
So has climate changed much in the past, or is it similar to the way it is now?
For example, 20,000 years ago during the last ice age, temperatures were much colder. During this time, giant ice sheets covered over half of North America.
If I were to go to a place like, say, New York, and look around, there would have been ice everywhere I looked?
Yeah, in fact, there's evidence that huge glaciers moved across the land. If you go to Central Park and Manhattan Island, you can see these giant boulders that were left behind when the ice sheets melted.
I'm assuming that our climate is still changing today. What are some of the effects of changing climate?
You're right, Matt. Our climate is changing. Two of the main issues that we're studying at the Hawaii Ocean Observing System are rising sea levels and increasing ocean temperatures.
So, Marcy, how do we observe something like increasing ocean temperature?
Well, there are many ways that we make observations about the ocean. In fact, why don't we see what the researchers with the Hawaii Ocean Observing System are doing on their boat today?
Oh, I think that's a great idea. Let's go check it out.
Great. Hi guys, this is Matt Limtiako with Navigating Change.
Nice to meet you.
Sergio and Jennifer.
Nice to meet you, Jennifer.
They're both with the Hawaii Ocean Observing System.
Awesome. Thanks for having us today.
Oh, pleasure.
Is there anything we could do to help out before we get underway?
We have a few things to load up. If you could help us, we'll get underway then.
Awesome.
Great.
Well, we use the CTD, that stands for conductivity, temperature, and depth, that we have on top of the vehicle there. And it measures temperature, so we are able to monitor how much the temperature increases or decreases over time, since we've been doing this for a while. And that would be directly related to the health of the coral reefs. All right.
20 meters. Drop it.
Yeah, let it go.
The amount of CO2 in the water affects how well corals can grow.
Okay.
So they're trying to monitor it and see what's happening in the water and how it affects whether corals keep growing or not.
1, 2, 3, go. Right, I'm gonna pull it gently off.
Okay.
We connect the remus to the computer and we communicate to it via internet or wireless communication. PA,
Okay.
that is the name of that
That buoy?
transponder.
Okay.
Yeah. So then we go here to single and we send a ping to it and it tells us where it is, 18 meters away from us.
Oh, okay. That's pretty accurate.
Yeah. 18 meters.
So now that we've gotten all this data collected, and where will all this data go?
We will put it on the web by the end of the week at our website at the Kilonalu Reef Observatory.
Okay.
And then we'll start doing science with it.
Well, this is-
analysis and the rest of the stuff to put it into context.
Well, thanks for having me aboard. This is really awesome. I learned a lot, and it seems like it'd be a really fun job to do. You guys seem like you enjoy your work a lot.
No, we do. It's a great job to have. It's pretty much a dream job. Anybody would love to do this.
Hey, Jen, thanks so much for having me. I appreciate you helping out.
Thank you for being aboard.
Wow, what a great profession to be out on the ocean doing something you love, and it's so important for our planet too. Thanks for having me.
Absolutely.
And now it's time for you folks to learn more about climate change as well.
In this climate change unit, we include PowerPoints that your teacher can present, links to websites, and activities to help you explore and understand climate change.
In the first activity, you'll see how temperature affects coral growth. You'll become part of a coral community in one of two places on our Earth.
Okay, so we're looking at the United States, the continental United States. Hawaii is out here. This is part of Mexico. This is Mexico. One of our coral communities, we're going to split you guys into two coral communities. One on this side is going to be in Mexico, and the other coral community on that side is going to be off of Florida. And so the colors on here tell you about the temperature. By following along in the PowerPoint, you and your coral community will experience temperature changes in your underwater world. You'll see how these changes affect the health of your community.
You guys ready to play the game? Yes! What reef are you guys? Mexico! The temperature maps you'll see were created using real satellite data collected during a year of unusual temperature shifts. White and purple represent cooler temperatures, while yellow and orange represent warmer temperatures.
The second activity in this unit focuses on sea level rise. In order to do this activity, you'll need to know that there's a difference between land-based ice and sea ice.
So, Marcy, you're telling me that there are actually different kinds of ice?
That's right. Land-based ice is of course formed on land. Some examples of that are glaciers or ice sheets on Antarctica, or even the ice in mountaintops.
Okay. So sea ice must be in the ocean, right? Is an iceberg considered sea ice?
You're right about sea ice, it does form in the ocean, but icebergs are considered land-based ice because they break off of glaciers, which are formed on land.
Now that we know that there are different types of ice, we're ready to do the sea level rise activity.
In the sea level rise activity, you'll create a model ocean with an island in the center. Then you'll be asked to hypothesize about how melting sea ice affects sea level and how melting land-based ice affects sea level.
You'll simulate this process in your classroom using actual ice, but we're not going to show you the results right now. You'll have to test that out on your own.
Okay, the setup. You and your team, you already know this, are going to create a model ocean with an island in the center. You'll monitor sea level as sea ice melts and then see what happens when land-based ice melts and flows into your ocean.
And seal it nice and tight. If this isn't tight, it's not going to work. So try to make it tight. And you can do that a little bit after you put the rubber band on.
You guys have to push it down so it's tight.
We need that.
And this glacier is flowing out into the ocean. But it's fresh water that started on land, and it didn't belong in the ocean. You know, it's supposed to be on land. And it started flowing into the ocean. And some of that is natural, but if you warm the ice, it starts melting faster.
Because we put it in, it took up space, but then now it says if it melts. But then if it melts, it's going to take up the same up space.
Once you finish the climate change unit, you'll have new knowledge to make educated decisions about your impact on our environment. Included in this unit are tips that you can share with your family.
Remember, every one of us makes a difference. Even making small changes in the way we live can help us all navigate change in our community.